This is 8.2. This talks about quadratic functions in vertex form. Last section we talked about quadratic functions. We started graphing parabolas and we started labeling every part of the parabola. And I mentioned the most important point, probably the most important point of the parabola is the vertex. Well, this lesson talks about quadratic functions in vertex form. And so what we first have to do is remind ourselves about the parent function. So the parent function, let me use this in blue. So y equals x squared. If you remember the xy chart that you need to be familiar with, and literally just know it, 0, 0, 1, 1, 2, 4, negative 1, 1, and then negative 2, 4. So the parent function will literally look like this, and if you wanted to do 3, 9, you could do the same thing. And remember, it's going to be symmetrical. It's literally reflective. All right, so that's the parent function. So what I want you to do, and I did this in blue, so that's the parent function. So what I want you to do is consider, what if I had something that looked like y equals x squared, just like the parent function, but what if I said plus 3? You know, what does that do to the parabola? Well, if I started graphing this, the xy chart, you know, if I plug in 0, 0 squared plus 3 is going to give you 3. And then the same thing with 1 squared, it's going to, it's basically going to add 3 to everything. So even if I plug in the same numbers, it's actually going to take the y column from the parent function, and it's going to add 3 to it. So normally I'd get 1 here, so I'm going to get 4. When I plug this in, normally I get 4 on the parent function, but I'm going to get 7, and likewise I'm going to get 4 and 7 on that. So if I graph that, notice the vertex of the parent function was there, but the vertex of this function in red, I literally moved it up 3 spaces. And if I graph the next point, 1, 4, notice it's here. Notice I took that point and I literally moved it up 3 spaces. So I can literally take this point and move it up 3 spaces. I could take this point and literally just move it up 3 spaces. Well, likewise, I could just move them all up 3 spaces. I'm moving this point up 3 spaces. I'm moving this point up 3 spaces. And so I can literally make my parabola. Notice all I did is I took the parent, y equals x squared, and I literally shifted it up 3 spaces. And so if I took, just as another example, so this number out here basically shifts the parabola. It's the same parent, I just shifted it up. Well, the same thing if I had y equals x squared, let's say minus 5. Well, this same parabola will literally, it's the same parent function, x squared, but it's being shifted down 5 spaces. So you could look at the XY chart if you want, but I'm literally just going to take the vertex and I'm going to shift it down 5 spaces. I'm going to take this point and I'm going to shift it down 5 spaces. Shift that point down 5 spaces. And I'm literally going to take each of those points and shift it down 5 spaces. And so when you graph your parabola, it's the same parent function, but it got shifted down 5 spaces. And you can verify these on your calculator. So I have the parent function x squared. I have the red one as x squared plus 3. And then I have the green one, x squared minus 5. And then if I push graph, you can see the exact same thing. The blue one is the parent function. The red one got shifted up 3 spaces, and the green one got shifted down 5 spaces. So the number on the outside shifts it up or down. So now let's consider, again, the parent function, y equals x squared. Same thing, 0, 0, 1, 1, 2, 4, and 3, 9. And again, I'm just going to reflect it over. That's the parent function. But notice in red, what if I had something, still the parent function, sort of. Well, it is the parent function, but it's being, something different is going to happen. So what if I had this right here? X minus 3 squared. So I have something with the x, but then it's being squared. Well, let's consider that just for a second. So let me erase my other ones from the calculators. And just to save time, I'm just going to use my calculator. We could make an XY chart. It's not that complicated. But I'm just going to show you on the calculator what this actually looks like. All right, so x minus, oops, I typed it in wrong. Let me just put it. So x minus 3 parentheses squared. So if I started graphing this, notice what's happening. The blue one is your parent function. The red one looks like the exact same parabola, but what happened to it? It literally got shifted over 3 spaces to the right. So it looks like a negative. I mean, it is a -3, a -3, but it actually, if some students look at it as like the opposite. So it gets shifted 3 spaces positive to the right. So that vertex got shifted 3 spaces to the right. Well, likewise, this point is going to be shifted 3 spaces to the right. This point shifted 3 spaces to the right. So each of these points gets shifted 3 spaces to the right. So that's literally all I'm doing is shifting it 3 spaces to the right. And then I can make my parabola. And so the number inside of that parenthesis looks like it's going to be shifting it. So let's play another scenario. What if on this green one, what if I had y equals x plus, let's say 5? And so, you know, it looks like a +5. So, you know, if you want to change, think of it as like you always do the opposite of what it says in the parenthesis. So that would be a like 5 spaces to in the negative direction. That's what I'm thinking. So let's plug it into the calculator and let's actually see if that's true. So x plus 5, and then all of that's in parentheses. I'm going to square it. Let's see what happens. Well, I was correct. So notice, again, I'm being shifting everything 5 spaces to the left now. So literally this vertex right here, I'm going to shift it 5 spaces to the left. And the same thing with this point, I'm going to shift it 5 spaces to the left. This point, I'm going to shift it 5 spaces to the left. And everything gets shifted over literally 5 spaces. And so that, you know, you're literally going to shift it, and then you draw this exact same parabola. So again, the number on the inside of the parentheses shifts it to the left or to the right. And recall this number on the outside shifts it up or down. So let's look at vertex form. So this is vertex form. So again, what I just now got done saying, the number on the outside shifts it up or down. The number on the inside of the parentheses shifts it left or right. And remember, it always looks like the opposite of the sign inside the parentheses. So if it was a negative, then you'd actually shift it to the right positive spaces. And then if it's a positive, you're going to shift it to the left. And then also remember this A. Yesterday in the video 8.1, we talked about what the A does out there. The A, remember, if it's being multiplied by 2 or 3 or 4 or 10, you know, those numbers actually make the parabola more narrow. And then if it's a fraction that's less than 1, like 1/2, 1/5, 1/10, those actually make the parabola wider. So that's something we need to always, so this makes it thinner or wider. Remember, thinner if it's greater than 1, like 2, 3, 4, 5, 6. So if it's greater than 1, then it makes it thinner, and it makes it wider if it's less than 1. All right, so let's consider each one of these functions. So we have, let me clear my calculator off. I'm going to keep the parent function as blue, and then I'm going to clear these others. So I'm going to type these in. All right, so each of these functions have been typed into my calculator, but before we go to the calculator, let's consider a couple things. So the blue one, remember the blue I'm going to use here is my parent function, so y equals x squared. That's my blue one, okay? And then I want to know, again, there's a 0, 0, 1, 1, 2, 4, 3, 9, and I'm going to reflect it over. That's my parent function. And each of these other functions, again, in vertex form, they're going to be shifted to the left or to the right, and they're going to be shifted up or down. And that's what we want to consider. So let's first look at the vertex. So the vertex, and again, I have it written right here, the vertex is HK. So the vertex is actually on this one, it's positive 1, because this looks like a negative 1, so it's actually positive 1, and then negative 3. So the vertex of the red is 1, negative 3. So if I go to 1, negative 3, it's right here. Notice what's happening. From the blue vertex to the red vertex, it's being shifted 1 spaces to the right, and it's shifted 3 spaces down. So I can literally, without the calculator, I can literally shift every one of the blue points. I can shift it 1 space to the right and 3 spaces down. And that's going to be the red function. So 1 space to the right, 3 spaces down. 1 space to the right, 3 spaces down. 1 space to the right, 3 spaces down. And so I can literally graph my red parabola, just by doing that, just to make sure I graph it. I can graph it just by shifting. I could use the calculator as well, but if you don't have a calculator, you can literally just shift it all of those spaces if you understand how the vertex form actually takes place. So the vertex of the green, again, the vertex is the opposite of what that looks there. So that's positive 1, 2. So if I go to 1, 2, the vertex is there of the green one. And notice from the parent function vertex is right there. That's the parent function. And it got shifted 1 space to the right and up 2. So it literally gets shifted 1 space to the right. So that's right or left. And this is up or down. So it literally got shifted 1 space to the right, 2 spaces to the right, 2 spaces up. So you can literally take every point, shift it 1 space over and 2 up. 1 space over and 2 up. 1 space over and 2 up. So you can literally do every single one of those points. And the same thing with my last parabola. Again, the vertex is the opposite of that, so it's negative 2, and that's negative 1. So negative 2, negative 1, the vertex is right there. And again, the shift is 2 spaces to the left, and then 1 space down. And so you can literally graph each one of these. Let me show you on the calculator. You can literally look at the blue one. The blue one is the parent function, and each one of those have been shifted, to the right or to the left, and it's been shifted up or down. So if I ask you to describe each one, you can literally, in words, you can literally just say this got shifted right 1 space and down 3 spaces. And you can literally do each one of those, how is it being shifted from the parent function? You always compare it from the parent function to be able to do that. And by the way, normally we don't graph, 3 parabolas, 4 parabolas on the same graph. But I'm showing you several problems at one time. Because we don't want to have it all confusing and showing 3 or 4 parabolas. That looks kind of confusing. We normally just graph the main function, that's what we're graphing, and then you compare it to the parent function. And that's vertex form.